In 2025, humanoid robots are no longer lab experiments. They are walking, working, and learning in real factories, hospitals, and test zones around the world. Humanoid robots are reaching a turning point. Advances in artificial intelligence, battery systems, and actuators are pushing robots closer to human-level movement and decision-making. Governments and companies in the USA, UK, and China are racing to deploy them at scale. This shift could redefine labor, defense, and daily life within this decade. Tesla Optimus Gen 3 is developed by Tesla, focusing on mass production and real-world utility. Boston Dynamics Atlas, backed by Hyundai, is known for cutting-edge mobility and dynamic balance. Unitree G1 represents China's push toward affordable, high-volume humanoid robots. Amica, built by UK-based Engineered Arts, focuses on human-robot interaction rather than physical labor. By 2025, Tesla Optimus has moved beyond demos and into controlled factory trials. Unitree G1 has entered pilot programs in logistics and research labs across China. Boston Dynamics has transitioned Atlas to fully electric systems, improving efficiency and precision. Amica continues to receive AI language and facial expression upgrades for public-facing roles. Modern humanoid robots use vision-based AI, depth cameras, force sensors, and real-time motion planning. Optimus Gen 3 uses neural network-driven perception trained on real-world data. Atlas relies on advanced balance algorithms and high-torque electric actuators. Unitree G1 focuses on lightweight design and cost-efficient motors. Amica integrates large language models, facial actuators, and emotion simulation for communication. In industry, humanoid robots are used for material handling, inspection, and repetitive assembly tasks. In healthcare, they assist with patient interaction, mobility support, and hospital logistics. In daily life, humanoids are being tested for reception, customer service, and education. In military and security research, humanoid platforms are evaluated for logistics and hazardous environment operations, not frontline combat. The USA leads in AI software, autonomy, and large-scale private investment. China leads in rapid manufacturing, cost reduction, and deployment speed. The UK leads in human-robot interaction, communication, and ethical design frameworks. Each region is shaping humanoid robots for different strategic goals. Between 2025 and 2030, humanoid robots are expected to move from pilots to limited commercial deployment. Analysts project early adoption in factories, warehouses, and public services before entering homes. Cost reduction and battery improvements will be the key accelerators. Current humanoid robots still struggle with fine manipulation, long battery life, and true reasoning. There are concerns about job displacement, data privacy, and autonomous decision-making. Regulatory oversight and safety standards remain uneven across countries. Humanoid robots in 2025 mark the beginning of a global transformation. They are not replacing humans yet, but they are becoming reliable partners in controlled environments. By the end of this decade, humanoid robots are likely to become as common in factories and public spaces as industrial robots are today.